Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video is for chapter 5, comparing three or more populations, and it's related to ANOVA for parametric test, and we call it for the non-parametric Kruskal-Wallis hash test. Okay, so this Kruskal-Wallis hash test is a test that we use to test the equality of more than two population probability distributions. As I said just now, it corresponds to ANOVA for more than two means under the parametric test. Okay, so for parametric test is ANOVA, and for non-parametric test is Kruskal-Wallis hash test, and is used to analyze completely randomized experimental design. So for this test, we compare with the distribution chi-square distribution with degree of freedom p minus 1. P here represent the population or the category or the group. Okay, and we can only use this analysis or test statistic only if the sample size, which is nj, for each group is greater than or equal to 5, means minimum 5 sample size for each group. Okay, so the hypothesis for Kruskal-Wallis hash test, hypothesis null we write down as the k probability distribution are identical, and hypothesis alternative at least two of the k probability distribution differ in location. This probability distribution is referring to the category k. Since it's ANOVA, minimum is 3 groups or 3 category. So the definition here, at least two of the k probability distribution differ in locations, mean at least there is two different in terms of location between these two probability distribution or category or group. Okay, so the test statistic used in this analysis is h equal to 12 over n times n plus 1. Okay, n is referring to the sample size, total sample size for the whole data, and the summation of nj, and j here represent the sample size for each category. And then we have the capital R, j bar, this is the sum rank for each group or category, and bar represent the mean for that category. Okay, the mean of rank for that category. And R bar here represent the mean for the whole for the total R. Okay, and then use squared. So that's the formula. Okay, so you see the test statistic. This is the hypothesis. As usual, we have 5 steps. You have hypothesis, and you know your alpha depend on the question given, and then you have your test statistic, and then you have your critical value from the table, which is chi-square. So let's look at the next slide. Okay, so this is the definition for each one of it. Nj, number of measurement in sample j. Rj is rank sum for sample j. Rj, this is bar, this should be bar. Rj bar, which is mean rank sum. R bar is mean of all ranks, and n is the total sample size. And this is the rejection region or your critical value. This one we get it from the chi-square table. Okay, provided that what is your alpha, and k minus 1 here is your degree of freedom. K is the category. If ANOVA minimum 3, so mean 3 minus 1, this is 2. So you need to refer to chi-square table with certain alpha and degree of freedom, and then you compare with your test statistic hash that have been calculated. Okay, as usual, when you rank the data, if there is type data or types, so you need to add the rank and divide by 2 if there's two type number or data. Okay, if it's more than 2, for example, you have 4 data with the same rank, so you need to divide by 4. Okay, so as usual, this is the condition required for the validity of the Kruskal-Wallis hash test. The k samples are random and independent, and there are 5 or more measurements in each sample, and the k probability distribution from which the samples are drawn are continuous. Okay, so this is the step how to carry out this test. First step, you need to assign a rank to the whole data, even though they have minimum of 3 category or 3 group. So you need to consider all data and you need to rank it to the whole data. Okay, and as usual, average the ties. Okay, any number that ties, you need to take the average. Second step, you sum the rank for each group and then compute the test statistic. Okay, so here this is RJ squared. This is total sum atau sum rank. You squared and divide by the sample size for that category or group. Alright, so this is the step. And then let's look at the example. As production manager, you want to see if 3 filing machines have different filing times. You assign 15 similarly trained and experienced workers, 5 per machine to the 5 per machine. Okay, sorry for the typo. At the 5% level of significance, is there a difference in the distribution of filing times? Okay. Alright, so we have 3 machines here. Machine 1, machine 2, machine 3. So for each machine, you have 5 trainer. 1, 2, 3. Okay, 5 times 3, so this one is 15 workers. Okay, so 15 workers for each machine 1 workers. Okay, so there are 15 here. So this is the data. So the question is, at 5% significant level, is there a difference in the distribution of filing times? Okay, so this is how you do it. First thing, your hypothesis null is identical distribution, which means for the first group, second and third group, they have identical distribution, and hypothesis and alternative, at least 2 distribution are different. Okay, your alpha for this question at 5%, so your alpha 0.05, and degree of freedoms is P minus 1. P is the category. For this case, we have 3 category or group, so 3 minus 1, your degree of freedom is 2. So the critical value here, you may refer to chi-square table. Okay, please remember chi-square table always skewed to the right. Okay, always skewed to the right, and the rejection region always at the right tail. Okay, for this question, we have alpha 0.05, so you may refer to chi-square table, alpha 0.05 and degree of freedom 2, you will get chi-square equal to 5.991. So this is your critical value. Okay, so after this, you calculate your test statistic and then you compare to this critical value. Alright, so let's look how you do it. So let's look at this data. So as I said just now, you need to look at all the data and you rank it across the group. Okay, so we can see that the minimum value here is 19.75. So that's why we give rank 1 for 19.75. And then what is the lowest after that is 20. So we give rank 2. And then what else? We have 20.4, 20.6, 22.2, and so on and so forth. Also from the other group. Okay, so this is the rank. Okay, so all this rank is cross group. So you treat it as a data, as a whole one lot of data, and you need to rank it from 1 to 15. And if there is a tight rank, you need to take the average. Okay, and then here is the sum rank. This is the rank for machine 1, 65. This is the sum rank for machine 2, 38. And this is the sum rank for machine 3, which is 17. Okay, next, you need to substitute all the information you have into the test statistic H. Okay, 12 over n plus 1. So n, your sample size is 15. So this one is 15 plus 1. Sum rank square. Sum rank for first group is 65. Sum rank for second group is 38. And sum rank for the third group is 17. So you just plug in into the formula. And then you got hash equal to 11.58. Okay, so what you need to do is you compare this hash value, test statistic, with the chi-square. Okay, with the chi-square. So since your chi-square is 5.991 and your test statistic 11.58 falls in the rejection region because it's greater than 5.991, that's why the decision is we reject hash null at alpha 5%. So what is the conclusion? So there is enough evidence to say that the population different distribution, at least two population different are at least two population are different. Okay, so maybe you can just edit here. There is evident population distribution are different, or the I think the better you write down at least two population are different. Okay, that is the conclusion. All right. So that is for Kruskal-Wallis test, which is the test for median or for distribution between more than two population. Okay. All right. So as usual, this is task 5, which will be counted as your attendance. So for this task 5, I give you some time for 2 weeks, just because of the system. I think UIMS system for UPSI is still not okay, and also just because next week I will outstation, so that's why I give you for both video today. So task 5, as usual, next week by end of next week you need to submit this task 5 in the my group platform, and I will consider that as your attendance. Whoever comment done and give your metric number at the comment platform in YouTube, and also submit the answer for this task 5 in my guru, then I will consider that as your attendance. Okay, so I think that's all for this video. Feel free to ask in our WhatsApp group if you have any question related to this topic. Okay, thank you. Assalamualaikum.